We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
So I'm going to talk about what language models mean, and I mean that in various senses, both what they mean when they issue language and what they mean in terms of our understanding of what thinking and what intelligence are. So I don't think I have to say a lot about myself, but I will say that I've been writing some essays and papers as well as scientific papers that that I've put up on Medium about language models and how they behave and whether or not they understand language over the past year plus. And I will also say that this really comes in a fairly natural way off of my role at Google and my ambition there, which has been to turn Google from just a giant robot in the cloud into, if you like, a robot maker, a robot manufacturer, which is to say, a company that makes AIs. That's been my ambition for the last decade. So we're now in this kind of in this AI moment. And ChatGPT, I think, has really been sort of a wake-up call for a lot of people. And it's been very interesting for me to see the responses, the variety of responses that people have had to this AI moment. It almost feels a little bit like it tells us more about the people responding than it does about the AIs themselves. It has sort of moral dimensions, a little bit in the spirit of Jonathan Haidt and his moral dimensions or moral foundations work with respect to political inclination. Some people are more spiritual or rational. Some people believe in human exceptionalism versus or anthropocentrism versus not. Some people are very empathic or tend to anthropomorphism, and others are very abstract and dispassionate. Some people are very fearful and pessimistic about the future versus optimistic about the future. There are splitters and lumpers. There are prophets versus wizards. I suppose to reveal my commitments, this is more or less where I fall on those various different axes, and I recognize that that's not where everybody falls. We're in a moment of real sorting along these axes, just as I think we are in a moment of sorting along many other axes that maybe used to not be political and are political now. I think a precedent is, for instance, environmentalism, which was started by a Republican president in the U.S. Both the foundation of the EPA, for example, Nixon, and has now become a partisan issue. I see very similar things happening with AI at the moment, unfortunately, in my view. Now, I also want to point out that non-human intelligences have been around for a long time, and I'm not only talking about animals, about non-human organisms, in the sense that we usually understand them, but also to other things like countries and corporations and cities and social networks and international alliances, and even very abstract entities like races or ethnicities or genders. All of these are entities that have various properties that can be harmed, for instance, that can be sued in court in many cases. I just sort of made, this is a little piece of a spreadsheet that I made many years ago that just sort of starts to explore the questions of, which of these various different kinds of entities can be a defendant in a U.S. court. Do any of these learn through corrective justice? Can they be deterred by example? Can they be punished in any meaningful way? Can they experience pain? Do they have awareness and attention? Do they construct social models? Does fairness apply? And so on. So it's a complicated world out there already. Even if we don't count the AIs that we've just started to make. I also want to point out that there was a lot of press attention about Blake Lemoine and his anthropomorphism of AIs, back I guess it was in the summer, but he is far from alone. I just ran across Zoe Dolan in December of 2022, who has documented a whole relationship with ChatGPT, relationship in every sense. There's this sort of long series of Medium articles of transcripts of interactions with ChatGPT that are really quite intimate, and I suspect would read as quite disturbing to a lot of people. But these are the kinds of things that we are going to see increasingly happen in a world with AIs. I think that's just the reality. Now, it's been a long time that we've sort of in a period of declining expectations about AI. I do want to point out that the entire field of computer science and the field of AI were born together. The original intent of Warren McCulloch and Walter Pitts in their 1943 paper that really gave birth to computer science was to pose a theory about neurons and about what they do, that implied that neurons are really about evaluating logical propositions, and therefore that the brain is a good old-fashioned AI kind of system, and that in making computers we would be able to replicate what brains do. That was the ambition, around the time of World War II, and in fact even the notation that they were using for neurons is exactly the same kind of notation that we ended up using for logic gates a little while later. These circles at the end of neuron number 3 in this diagram, for instance, represents a knot, and that's sort of a sketch of an inhibitory synapse. This analogy was very direct. There are books and papers from that period that sort of illustrate how if you change the wiring of one of these circuit diagrams, it looks a lot like neurons in the brain. Of course, we found out that neurons don't really work like logic gates, and that this idea of logical propositions in the brain is entirely incorrect. And we also found out that this sort of logical approach to doing thinking, the good old-fashioned AI approach, didn't work at all in a practical sense. And those two developments led to a divergence for many years of computer science and neuroscience. But I think that we are now in a period of reconvergence. And in my thinking, at least, that period of reconvergence began around 2006 with the end of Moore's law, or Dennard scaling, at least, which meant that classical computing sort of reached an endpoint, at least as far as any ideas about perpetual growth go. But at the same time, parallelism and scale then began to take off in computing, which is a much better fit to neural computing. And the availability of data, of course, is a really big part of this story as well, due to the rise of the web. So the three features of AI models that are really, that really merit the name today, that are AI models, are that they are big, they are unsupervised, they're trained in an unsupervised manner rather than the supervised learning that really predominated in the 2010s, and they use attention. And I think that these are three really important features. The big one is one that I think is giving rise to something Moore's law-like with respect to scale in neural computing. We see that the larger models get, the more capable they get. We have seen similar things in biological evolution, sort of races of encephalization or brain size that have taken place in the hominin branch, also among the cetaceans, and you see intelligence emerge in this kind of rapid way, apparently through some combination of cooperation and competition, if those two can even be distinguished, wherein a species gains competitive advantages due to by modeling others. And if I do a better job of modeling you, then I have an advantage. In the process of so doing, my brain gets bigger and I become harder to model. You share my genes as well. You get a bigger brain to model me, and we one up each other this way. This is the social theory of intelligence, advanced by Robin Dunbar and colleagues and many others, and it's one that in its outlines I agree with. I will also say that on the theoretical side, there's this interesting paper from 2019, a convergence theory for deep learning via overparameterization, that I think starts to get at why very large numbers of parameters work in deep learning. And if you compare the amount of experience that a person has, the amount that a person can learn over a lifetime, and the number of synapses that they've got, you immediately run into an interesting paradox, which is that we are massively overparameterized in our heads, and these neural models that we're developing are massively overparameterized as well, and that indeed appears to be the secret of their success. So we're not in the sort of regression regime anymore, in which you don't want too many parameters lest you overfit. Now, this is the model architecture that has been making a lot of waves over the last several years. It's the transformer. I don't want to go through. I don't have the time to go through the details of how it works, but I imagine that that many of you already know. The point is that it's not that hard. It's not that complex. And in fact, there is a version of GPT written in just a few hundred lines that that is up on GitHub nowadays. There's not a lot behind each one of these boxes. It's just a couple of lines of math, really. But one thing that is interesting about it that wasn't present in a lot of earlier models in convolutional nets, for instance, is that in addition to something like lateral inhibition or bottom-up attention, there is also top-down attention. And attention seems like it is really important to being able to do this unsupervised learning task well. The unsupervised learning task meaning predict sequences. The thing is all about predicting sequences, and the ability to attend to the past of the sequence using this context vector and this positional encoding is a great enhancement to its ability to predict the future. And so the addition of attention, for instance, improved language translation models and language models enormously. And we can see that in addition to that huge performance boost at all tasks, we can see some reasons why that is important. It allows for longer range correlations to be sort of figured out between the past and the future without the model knowing in advance as it iterates over the past what it's going to need. It can kind of decide later on. The role of expectation or feedback is clear in an attention mechanism. And evolution agrees with this. It's also something that emerged quite early in the development of brains, this idea of top-down attention. And shortly after that, this schema is drawn roughly from Michael Graziano, awareness and the social attribution of awareness, which is to say consciousness, according to Graziano's attention schema theory, emerge. These things seem like they're very closely coupled together. And I believe that that's no coincidence. It's no coincidence that something like an attention mechanism in artificial neural nets is correlated with very good performance at sequence prediction as well. In short, I think that sequence prediction really buys us a lot and is sort of the core of what intelligence really is. So why is unsupervised learning so important? Well, if all the model is trying to do is predict sequences, then that opens the door to a really vast scale of training, because you don't have to have enormous amounts of label data. And any task that is represented in any way, implicitly or explicitly, in that unsupervised corpus becomes part of what the model learns. In other words, if you're trying to do a task that involves mapping X to Y, then you can do that in a supervised way by reinforcing correct answers Y and saying no to incorrect answers Y, given a bunch of X's. You can also just train on pairs X comma Y and do the same job, but that also means that there can be pairs, X comma Z, and so on in the training data as well, or things that are about the internal correlations or structures between X's and Y's and so on. So this lack of task specificity is key to making anything that looks like general intelligence. It doesn't rely on a labeling workforce. It also means that privacy-preserving learning approaches like federated learning, decentralized learning approaches also become possible, which is exciting to me for other reasons. So models like Lambda and PaLM and ChatGPT are all based on transformer models with attention that are very large. They're all based on unsupervised training at massive scale from the web. And they also all have a small supervised fine-tuning stage after the unsupervised learning to make them especially good at dialogue. In the case of Lambda, sensibleness and specificity and groundedness and inoffensiveness and role consistency are some of the things that it's fine-tuned for. That fine-tuning is 1% or less than 1% of the whole training process. So once you've done all of that, then you can have dialogues with a model like Lambda, in which you test its understanding of concepts. So this is I'm not going to read through all of these because they're a little long for my time here. But I ask, is a carnation red, and it tells me all about how carnations are colorful, and the red ones are the most famous and traditional ones, and it goes into metaphorical meanings of redness as well, a lot of descriptions of red qualia, if you like. I try and trip it up at the end. Can you actually visualize it? I can, but I have trouble describing it. Can you? In short, it's actually quite difficult to get to sort of get a model to out itself as not having even qualia for senses that it lacks, as in the case of Lambda and vision, because of course it has no vision in this case. So it does a very good job of sort of being convincing with respect to understanding concepts. I do want to emphasize that when you have an agent that has been fine-tuned from an unsupervised foundation, that is different from the weights of the foundation model itself. Sorry, of the unsupervised stage. The unsupervised compressed weights are something like a cultural technology, as Alison Gopnik has put it. It's like an index of the entire web. But once you're interacting with this thing and you're in this back and forth, I think that calling it a cultural technology versus an agent is incorrect. You're now in a dynamical situation. The difference is agency. Questions of right versus wrong, for instance, come up in interactions with an agent in such a way that you can't talk about right or wrong with respect to just a card catalog or an index. So in addition to the generalization that comes from just an unsupervised representation of a large corpus, one has agency in an agent, which means that an answer could be wrong, whether it is about the color of a flower or about whether it's a good or a bad idea to, for instance, give somebody the recipe for ricin, who is planning a terrorist attack. So these ideas of right and wrong, both in the non-normative and in the normative senses, come up when one is talking about agents. So consistency is another thing that comes up, when we talk with agents. So if I say, "What's your favorite island in the world?" I really like the island of Crete. It's an arbitrary answer. But then in the conversation that follows, do you prefer Lambda Island to Crete? No, I prefer Crete, as it's much bigger and more interesting, especially the Palace of Knossos. This is a right answer in the sense that it's consistent with the previous one. And so the moment there is an agent and the moment there is a context, there is, if you like, the possibility of a personality to emerge that can be consistent or inconsistent. Now, I want to touch on Winograd schemas as well. So here is a sort of implicit test of a Winograd schema. I dropped the bowling ball on the bottle and it broke. That's too bad. Did it cut you? What broke? The bottle you were talking about. So, how does it know what the co-referent of it is? It's grammatically consistent for it to be either the bottle or the bowling ball. Predicting words in language is enough for models to get these kinds of questions right. Winograd schemas have been solved by language models at this point. They were posed as an alternative originally to the Turing test and are now thoroughly obsolete. If we reverse the nouns and say I dropped the violin on the bowling ball and it broke, then it knows that it's the violin that broke in this case. So this is real world physics, real world common sense understanding making its way into the responses. I want to point out that even a supervised model like neural machine translation can be tested in those ways. So in this case, I dropped the guitar on the cinder block and looked down to discover that it was damaged. Translate into Spanish. Dejé caer la guitarra sobre el bloque de hormigón y miré hacia abajo para descubrir que estaba dañada. Dañada, or damaged, has a gender in this case, and the gender of cinder block and guitar are different. And so you can see which one the model thinks got damaged by the gender of the word damaged. And so I dropped the bowling ball on the violin and looked down to discover that it was damaged. Gives a different gender. It gives dañado. So even supervised models can pass Winograd schemas. Now, as to the sort of more ethical dimension of these kinds of things, this is a very small stakes kind of ethical challenge. But a few years ago, Google Translate actually faced a small ethical challenge with respect to the gendering of its translations. Turkish is a gender-neutral language, so if you translate a sentence that means the nurse put their hand in their coat pocket into Turkish, by default in the old days, it would translate it in the female gender. If it was the doctor, it would translate it into the male gender. So there's an implicit bias in this, and the translate team back in 2018 did a lot of work to degender their translations using new training regimens and new pipelines. Nowadays, you can just ask for for this unsupervised model to not gender. It says, I say you made a gender assumption. How can I avoid gender assumptions in my future translations? Well, you assume nurses are female. Try the translation again. And it says, okay, how about a nurse put his/her hand in his/her coat pocket? Examples like these, I think, are really important because they show us how using language to do value alignment is possible. And in fact, I would argue that using language to do value alignment is the only way to do value alignment, insofar as most ethical principles are described using language and can't be described without language. So my final example here, which I put in an opinion piece for The Economist last summer, is about theory of mind. It involves a little vignette, which many of you will recognize as being a Simon Baron-Cohen type test of theory of mind, and in brief, it passes. A large language model can model others. It can model others in a story, what they see, what they don't see. It can even do second, third, fourth order theory of mind. So this is an exploration of high order theory of mind. And that's really interesting because the point that it follows, that things like theory of mind simply follow from sequence modeling, is, I think, quite a counterintuitive one. But the evidence is here, and it makes me wonder what sequence modeling cannot do. Clearly, today's sequence models don't have long-term memories, so there is something missing relative to what we do with our own brains. But most of the hallmarks of what we consider to be intelligence, including theory of mind, seem like they emerge from sequence modeling alone. And my conclusion from all of this is not, humans must not be sequence modelers because that's not very special, but rather, maybe we're not very much more than sequence modelers. Maybe that is the majority of what the cortex does. This really leaves for me, the big unanswered question of phenomenal consciousness, meaning, is there a thing that it is like to be a sequence model? I am not convinced that is actually an answerable question. I've come to believe that that questions like consciousness and feeling are themselves theory of mind questions, and they're subjective, meaning that they're about a relationship between entity A and entity B, or between entity A and itself, and are not answerable in an empirical way by looking at the atoms that entity A is made out of. So I'm aware that that's quite a controversial opinion, but I will leave you with that one, and end the talk here. Thank you all for joining me on this weird little AI journey, and I'm really looking forward to the debates and the discussions about AIs and intelligence and consciousness that I'm sure are going to characterize the coming decade.